class. And good morning, everyone, to the Saturday morning live session with me. And as you know, the topic it remains the same that I was doing yesterday. It's important questions on number systems. Part 2 is what we are doing today. And I've got some interesting questions scheduled for you here. Just give me a second. Let me bring out the right PowerPoint window and a paint window for writing the solutions here. So yeah, so the first question for you is what you see here on your screen, and I first want you to try to solve this on your own, and then we'll move on to discussing this question. Let me just reorganize the page, so the window, so that you can see everything here. Right, so I guess the question, as you can see, is an intelligence agency forms a code of two distinct digits selected from 0, 1, 2, 3 up to 9, such that the first digit of the code is not 0. First digit of the code should not be 0. Right, let me try to play this on a right, so the code handwritten on a slip can potentially create confusion when read upside down. For example, the code 91 may appear as 16. So let's make sense of that. If you write the number 91, and you turn the page upside down, and if you don't know the top of the page and the bottom of the page, then this number would turn out as 16. Right, so 16 and 91 will look opposite each other. So the question is asking how many codes are there for which no confusion can arise. Right, so first of all, because it's a 2-digit code, you start off by thinking that there are 90 such codes starting from 10 to 99. Right? There can be 90 2-digit codes that can happen. And out of those 90 2-digit codes, some codes will cause confusion, others will not. So we are looking for how many codes are there for which no confusion can arise. So if we start thinking about this, you first need to identify the digits that will create a confusion upside down. We have just seen in the example of 91, we have just seen two kinds of digits that create confusion upside down. One is what happens with the number 9. If you turn it upside down, it looks like 6. Right? The other is the number 1. The other category is number 1. If you turn it upside down, it still looks like 1. So 1 looks like 1, but 9 looks like 6, and 6 looks like 9. So there are two kinds of numbers here that create the problem. The numbers which on inverting will change the values, and numbers which on inverting will not change the values. So for a number like 11, for example, you turn it upside down, the page, you will still be confused about the top and the bottom of the page, right? Because the slip is handwritten, the numbers are handwritten on on a slip, and that slip can cause confusion when read upside down. But 11 will not cause a confusion, because 11, if you invert it, will still look like 11, right? But 91 will cause a confusion because it look like 16, as the example stated there. So based on this understanding, we can start looking at, first of all, what digits are there that will create a problem. So if you look through the digits, 0 is a number which will create a problem on top and bottom. 1 is a number which will again create a problem on top and bottom, although it will look like itself by when you invert the page. 2 will not create a confusion, because if you invert the page, it will look upside down. 3 will not create a confusion because it will turn around if you invert the page. 4 will not create a confusion. 5 will not create a confusion. 6 would create a confusion of 9. 7 will not create a confusion. And 8 will create a confusion like 1, because it's opposite to, I mean, you turn the page down, upside down, it will still look like 8. It will not show a different number. But a number like 81 can appear 18 because the order of the numbers will change. We can see this, a number 18. If you look from here, it's 18. And if you look from that side, this number is 81. So based on this understanding, we can start trying to work out the codes on which there will be confusion. So given the fact, one more information is important in this question, and that information that is important in this question is that the first digit of the code is not 0. So that information is important because if you write a number like 10, you turn it upside down, it look like 01. And 1 will not cause a confusion, because you know that you are having only 2-digit codes, right? So if you go ahead and think now from this point, what comes to mind is that we'll get numbers in the tens, the 60s, the 80s, and the 90s, and there will be confusion only when there is combination of 2 of these 5 digits created. So if you look through the tens, 10 will not create a confusion. You have to look at 10, 11, 16, 18, and 19. In the 60s, you have to look at 60, 61, 66, 68, and 69. In the 80s, you have to look at 80, 81, 86, 88, and 89. And likewise in the 90s, you have to look at 90, 91, 96, 98, and 99. These are potential causes of problems, or causes of errors that can happen. And 10, 60, 80, and 90 will not cause a problem because they'll look like 01, 09, 08, or 06. And since the code can't start with 0, you will not have a confusion on those numbers. So if you go ahead with 11, 11 will look like 11, so that's not a problem. So if you look at 16, 16 will look like 91. And that's something which is already mentioned in our problem here. the code 91 appears as 16 or 16 appears as 91. So we have a first two numbers which will create a problem. First pair of numbers which will create a problem, 16 and 91. Remember, we are going to subtract this. The number of questions that create a problem, we are going to subtract that from the number of questions, number of numbers that are available in two-digit numbers. So that's from 90. So we are going to subtract all these from 90. So if you look at 18, 18 will cause a confusion of looking like 81 if you look at it upside down, because the left to right will become, if you invert the page, the left to right will become 8 on the left and 1 on the right. So 1881 is another pair which cause confusion. And you can start thinking 19 and 61 also, because 9 looks like 6. Right? So that's 6 numbers which are causing confusion. 60, as I've already said, will not cause a confusion. 66 will cause a confusion of 99. 66 will cause a confusion of 99. 68 will cause a confusion of 89. 68 will cause a confusion of 89. 69 is an interesting case and you need to be careful about this. If you look at 69, from the bottom it looks like 69. If you look at 69 from the top, it still looks like 69. So one of the mistakes a lot of people did was they use the pair 6996, but 6996 pair is not going to be used, just like 96, whether you look at it from here 9 and 6 or you look at it from there 9 and 6, both these will remain same. Right? So 69 does not cause a problem. So we move on to what causes problems. So if you look through, 81, 18 we've already taken. 86 is the next number on our list, and you should be able to see that 86 will look like 98. 86 is going to look like 98. '86 is going to look like 98 when you invert it. So this is another pair. And 88 will look like 88 itself, so that's not going to cause a problem. So what you can see is that there are a total of 12 numbers that are going to cause the problem from 90, and hence now there's one more catch in this question. The question had said that the number of numbers are, you are making numbers from distinct digits. So if distinct digits are there, 66 and 99 is not going to be done. And also one more modification you have to the problem is that the number of numbers which you have, the first digit can be anything between 1 to 9. So 9 ways of selecting the first digit. And the second digit can be anything from 0 to 9 except the number used in the first digit. So there are a total of 9 into 9, 81 numbers with distinct digits. And from there, we have to remove the 6699 pair also. So actually there are 10 numbers like this which are going to cause a problem out of the 81 numbers. And hence the correct answer is 81 minus 10, which is 71. So 71 codes are going to create a problem in this question, and that was the question in this that was asked to us. So this is the next question for you. Try this. So this question says, suppose n is an integer such that the sum of digits of n is 2. Sum of digits of n is 2. And n is between 10 raised to 10 and 10 raised to 11. That means 10 raised to 10 means 1 with 10 zeros. N is greater than that and less than 1 with 11 zeros. Right? So in this scenario, what is to happen is you can clearly see that if the sum of digits is 2, then I can create the sum of digits 2 by using 1. So what you need to realize is that because it's less than 10 raised to 11 and greater than 10 raised to 10, the number n would basically be an 11 digit number. The number n would basically be an 11 digit number. And for n to be an 11 digit number with a sum of digits of 2, you can have a sum of digits of 2 by two numbers. So there are 10 digits apart from this 1. So if you put a 1 in any of those 1 digits, you will get a sum of digits of 2. So for example, this is an instance of a number that gives you a sum of digits of 2. This is an instance of a number that gives you a sum of digit of 2. And likewise, you can clearly see that if you shift the 1 from here to this place, the sum of digits will still be 2. So basically, as far as this 1 is fixed in the starting place, the other one can vary between 0 to between any of these 10 digits. So starting with 1 1 followed by 9 zeros, or 1 0 1 followed by 8 zeros, to 1 and then 9 zeros 1. All these numbers will add up to 2. Sum of digits would add up to 2 only. So these are 10 such numbers. And then don't forget to count the number 2 followed by 10 zeros. This number will also have sum of digits of 2 only. So the total value would be 10 plus 1 or 11 such numbers. Right? So I hope you enjoyed that question, and hence the correct answer is option A. Another way to help yourself visualize these questions better is to try to think about smaller numbers. So suppose I change it to n is greater than 1000 but less than 10,000. So you will be able to see the logic easier, that if I want sum of digits 2 with 2 ones, I have 3 such numbers, because the second one can move value wise. The second one can move value wise from the third place, second place to the first place. So there are 3 numbers like this, and 1 number with 2 followed by 3 zeros. So there's 1 number like that. So a total of 4 numbers would be the answer here. And the only change when it becomes 10 raised to 10 to 10 raised to 11 would be that this will become 10 plus 1, which is 11 numbers. Right? So the third question that I have for you is this one. And the question says, let S be the set of integers x such that S be the set of integers x such that 100 is less than equal to x is less than equal to 200. X is odd. And x is divisible by 3 but not 7. So the question is talking about how many numbers exist for x. What are the number of values that exist for x? So this is a question which is somewhere between number systems logic and progressions logic. So I'm giving you a minute or two to think about this. Try to solve this on your own first, and then you can look at my solution here. So okay, so let's try to think about this question and let's try to solve this. The first condition for x is that x is odd. So that condition basically eliminates all the even numbers. So we're left with 50 numbers here, starting from 101 to 199. There are 50 odd numbers here, and that counting, whenever you have to count the number of terms in AP, you should use the formula d by d plus 1, where capital D is the difference between the first and last number, small d is the common difference of the AP, and plus 1. So in this case, if you look through, you will see that the difference between the number 101 and the number 199, the difference between these two numbers is 98. So D is 98. The common difference is the difference between 101 and 103, which is 2. So small d is 2. 98 divided by 2 plus 1. That gives you an answer of 50 there. So you always use this formula. Remember this formula. Whenever you want to find the number of terms in an AP, d divided by d plus 1, capital D is the difference between the first and last terms, and common difference small d is 2. So this is Tushar, this is after I've taken the first condition into account, that x is odd. Now the second condition is that x is divisible by 3. So once we have reached this point and we are looking for numbers where x is divisible by 3 only, we can make this series 105 odd numbers. We are only down to odd numbers between 100 to 200. So 105, 111, 117, 123, and because 123 is part of the series, 183 will also be part of the series. So the series ends at 189 and 195. So odd numbers divisible by 3 between 100 to 200. We have created this. We have created this list already. Right, and again, how many terms there are in this? D divided by D plus 1. Capital D, difference between the first and last numbers, 90. Divided by small d, difference, the common difference of this AP, 6 plus 1. There are a total of 16 terms in this AP. Right? Now, the third element or the third filter has still to be applied on this. And the third filter is not by 7. So there are 16 numbers that obey the first two filters. They're odd numbers and they're divisible by 3. But when you introduce the not by 7 condition on this, not divisible by 7, so you will have to read out the numbers which are in this and are also divisible by 7. So you should be able to see 105. Now the series of divisible by 7 would be 105, 112, 119, but we can ignore the the even numbers because they are no longer there in that list. So that series is 105, 119, 133, 147 up to 161, 175 and 189. So in these 16 numbers that you have, how many numbers are there in this series? Once you can find that, you have to subtract it because this is the condition you have to eliminate. If the number is odd, divisible by 3 and also by 7, then you don't have to count it. So very clearly 105 should not be counted in this 16. So the key question becomes how many numbers there are which are common between these two series. That is the subtraction of the 16 to get the answer. And for two APs, the best way to do number of terms common, for two APs, the best way to do number of terms common is to understand that the common terms between the APs will also be an arithmetic progression. The list of common terms between the APs will also be an arithmetic progression, and that arithmetic progression will have its first term as 105, which we already see is there in both. The key is the next term. Now this is a series. When you're writing this series, this is getting added by 14, common difference of 14, and when you're writing this series, it's a common difference of 6. Now this common terms AP will itself be an AP with a common difference, which is the LCM of D1 and D2. So in this case, it will be the LCM of 6 and 14, which we know as 42. So you can predict if 105 is the first common term, which you can see here, you can predict that the next common term would be 147 and the third common term would be 189. So there are 3 numbers less, and hence the correct answer here is going to be 13. The total number of numbers which have this property are 13. So right, I hope you enjoyed the class. Number systems is an important part of your syllabus, and as I was mentioning yesterday, repeating it, number system is something you should not underdo. There's a lot of tendency this year of people underdoing number systems because it's not been asked much in the last 2 years. But CAT has a way of surprising you by pulling out exactly what you feel will not happen. So don't underestimate number systems. Your focus for CAT and number system has to be one of the focus areas. If you're using my books, the Arun Sharma books, then this is part of block 1. So don't underestimate block 1. It can make a big comeback this year. And hopefully some of you can also look at one last thing before I wind up, is the Unacademy Plus subscription model, where on Unacademy Plus you have access to great courses and great teachers, handpicked and selected from across India, uh, for various competitive exams that you can prepare for: CAT, UPSC, banking, SSC, and so many other exams, CTET, etc. So, if you do want to check out Unacademy Plus, please do head over to the website. And under the CAT subscription model, I'm one of the teachers along with a host of 15, 20 other good, great educators who are there. The best part of the Unacademy Plus subscription is that once you take it, you get access to all the teachers and all the courses. So if you do decide to take up the Unacademy Plus subscription, please use my promo code. The promo code is Arunmsharma. It'll give you a 10% discount on the existing fees and the existing already discounted fee. You'll get a 10% extra discount if you use this promo code while registering. Arun Sharma. So please look forward to watching these sessions. Look forward to coming back to you in the next session in 10 minutes, and look forward to having some of you on Unacademy Plus with me. Right. So I'll wind up then. Thank you so much. Bye for now.